Hello, Marvelous Algebra 1 students, and welcome back to lesson 3.4. This is actually our final lesson in topic 3, and it has the wonderful title Comparing Functions. We know when we compare two things, we look for similarities or differences. And before we get started comparing functions, we're actually going to do a quick opener to remind you of a few important key concepts about functions. The first thing we're going to do is look at a line, an equation of a line, that will pass through these 2 points that are given to us. Now, in order to write the equation of a line, we know we need a slope and a point. Let's take a quick peek at the answer choices though, since this is multiple choice, and that might guide you on where you need to go. And then once you have that guidance, you can pause this video and try the opener. So as I look at each of the 4 equations down below, it looks like they are not in slope-intercept or mx plus b form. Instead, it looks like these are all pretty much in hk form. And we should remember our hk equation, mx minus h plus k, and make sure we go through and identify the key parts of each equation. The first part, of course, is our slope that's out front. And we might notice that our slopes are just 2 different numbers, either positive 3/2 or negative 3/2. And so that means you'll probably have to figure out the slope of these guys. Do you remember how to find the slope? Right? Our slope is m equals y sub 2 minus y sub 1. The y's are on the top. It's the rise over the run. The rise is the y's. x2 minus x1. So I think in terms of hints, that might be all you need. You'll probably want to find the slope first, and that'll let you eliminate 2 options. And then you're going to have to think about that HK part of a line and how we use one or maybe both of the points to write our line. So go ahead and pause my video. Take a few minutes so it looks like you and most of your classmates have gotten this problem done, and then unpause so we can run through it. Ready, set, go. All right, welcome back. Hopefully you guys found some success. Let's start with our slope here. Slope-wise, we want to go through and label these. We know points go x comma y, x comma y. The first x I come to is this 3/2, so I'll label it as x sub 1, or the first x. This, of course, means this must be my first y. This is the second x I got to, and 8 is the second y. So let's find our slope. Slope-wise, I'm going to put these 2 sets of parentheses here. I might need a little more room. I'll put my HK form back later on. Let's substitute these in. Y sub 2 comes first, and that's going to be our 8. Y sub 1. And then we have x sub 2 and x sub 1. Now, if you switch the order of these, that's okay. As long as the y's are on top, x's are on the bottom, we should get the same thing. 8 minus 5, we can certainly do, that's 3. But then we need to look at the bottom. Now, this bottom has those scary fractions here, and we'll kind of do that zoomed in look at negative 1/2 minus 3/2. Negative 1/2 minus 3/2. Friendly reminder for fractions, the tops or the numerators are counting how many of the denominator you have. So for this first fraction, we have negative 1 of these halves. And the second fraction, you have negative 3 of these halves. So if you have negative 1 of something and you take 3 more away, I think now we have negative 4 of that thing. Once we're here, negative 4 over 2, okay, we can put this in, negative 4 over 2. You'll notice that this doesn't seem to match any of our slopes in blue. Oh, but we should probably simplify this, shouldn't we? Negative 4 over 2 is just a fancy division problem. It means negative 4 divided by 2, and that is negative 2. So we can go through and we can say, oh, okay, well, we know our slope is negative 3/2. I think that eliminates options B and A. Or visually, what we actually did here is if you wanted to graph these points, you could. It might not be a perfect graph, though I did prepare a graph for you. I went ahead and graphed those 2 points. By graphing these points, they don't have to be perfect. Can we see that the line that connects the 2 of them would have to have a negative slope? Right? It goes down 1, 2, 3 over 1, 2. right? Down 3 over 2. So just by graphing them, you could already eliminate 2 of your multiple choice answers. And as a reminder, the ones we eliminated were positive slopes. Watch when I turn one of these positive slopes on. This line only goes through one of the points. Same thing for the second one. This doesn't actually go through any of the points, so those are definitely wrong. Okay, so we've eliminated A and B. We're now down to C and D. So if we look at C and D, we need to think about the other 2 numbers in the equation. I see 2 numbers here and 2 numbers over here. And as we've learned in the past for HK form, right, we know that these numbers hiding actually form a point. And I'll do the same thing over here. Okay, point-wise, it looks like negative 1/2 comma 8 and negative 3/2 comma 5 might be our points. Now that we have the 2 points, let's check to see if they match either of the points that were given to us. The first point is positive 1/2 comma 8, which almost looks like this one, but notice they gave us the wrong sign in here. I think that's probably a false scent trying to throw us off the trail. In fact, let's take a look at part C. I have the graph prepared for you over here. Yeah, look, it doesn't go through either of those points, right? Positive 1/2 comma 8 would be this point right here, right? Give or take. There we go. And so it passes through that, but not either of the other 2 points. So I think that one's not it either, which means by process of elimination, we're looking at D. And you'll notice D does have a point that was given to us, 3/2 comma 5. So this line then has a point of one of these 2 points, and it has the slope that matches the 2 points. And if you were able to graph it, you'll notice that when I create this graph, it does pass through the 2 given points. All right, let's go ahead to our main event for today, because we're not actually learning anything new today. Instead, we're putting our skills together, and we're going to try and compare linear equations. You're going to be given 2 or sometimes more than 2 different lines. And sometimes the lines will both be given as graphs. Like in problem 1, we have a graph, and they're going to ask you questions about the 2 different lines. However, sometimes you might get one line that's a graph and another that's an equation, or you might get a line that goes between 2 points, just like the opener, and a line that is presented in a table. And we need to be able to compare different features of those lines no matter how they're presented to us. Okay? For example, if you're given 2 lines, can you determine which line is steeper? Well, if we're talking about the steepness of a line, that's where you'd have to be able to find the slope. You'd have to ask yourself, can you find the slope for a line graphed? Well, sure, rise over run. Can you find the slope of a line in an equation? That can be a little trickier. Or can you find the slope of a line presented as a point or in a table? And that was just our slope formula that we just practiced. Another common question is, which line crosses the y-axis at a higher value? Well, if you're looking at that, then you're going to have to find the y-intercept for each line. And again, sometimes that's not bad. If you're looking at graphs, here are the different y-intercepts. Clearly, this one is a larger y-intercept. But if you're looking at equations, we need to remember that for y-intercepts, you need to plug in those zeros. In fact, this one asks about an x-intercept, doesn't it? So reminding for an x-intercept, that's when y is 0. You remember that technique? Or, I mean, if it's a graph, that's not too bad. And even trickier, if you look at equations that are given down here and they ask you about x or y intercepts, you also have to think maybe about writing an equation and then plugging in zeros, or thinking about points with zeros to maybe help you out. Now, what I'd like you to do is actually work with a partner, a different partner for each problem. And when you get to your partner, you're actually going to switch papers with them. So if I have my paper and I'm working with my partner Stefan, I would give Stefan my paper, I would take Stefan's paper, and we would go through, work together, but we're doing the work on the other person's paper. Once you guys have worked together and found the answer, you need to send one of your 2 partners up to the teacher. The teacher is going to stamp your paper or sign your paper, or even just say it's okay if they don't have any of those available. And then you're going to go back to your seat and sign your name at the bottom of your partner's paper. Then you're going to switch your paper back and move off to a new partner. Now, if your new partner is still working on this problem, you can definitely go over and give them some hints. However, you shouldn't pull your paper out. Your paper should stay face down, and if you want to try and help them get through problem 1 so that they can do problem 2 with you, then you would do something like, oh, on problem 1, you're like, oh, well, don't forget the rise over run. Give them hints, help them get there so that they can move through the problem faster than get caught up with you. Now, the other thing we might do, depending on if your teacher is there or not, is your teacher may just ask you to work with one partner, and then every few minutes they might unpause this video and have me work through it so that you can see if you did it right or not, right? Maybe your teacher doesn't have a background in math or something like that, and we want to make sure that you're comfortable with this style of problem. So either way, your teacher will explain the instructions to you. I would prefer that you work with a different partner on each problem. Part of life is being able to work with different people, get along with different partners. And we only have 1, 2, 3, 4, 5, 6 total problems for today. So hopefully that's not too terrible. But why don't you guys figure out your partner for problem 1, okay? And then pause this video and get started. Maybe take no more than I'd say 5 minutes on problem 1. Probably should only take you 1 or 2 minutes. And then unpause the video. Or if your teacher's pretty confident with math, check it with your teacher and then move on to find a new partner. Ready, set, go. All right, and we're back to problem 1. Hopefully you guys found some success on this. They asked about the larger rate of change, so we needed to remember that the rate of change is that fancy phrase for slope. So to find slope, we find a couple of those nice points on our graph, those integer points. And I'll do the same on each one. Let's try to color coordinate this though, something like this. And then we need to actually find the slopes. So our first slope, we go up 1 over 3, it looks like. And our second one, it looks like we go up 1 and over 2. So let's jot those slopes down. This first graph is called f of x, and there's a space down here for f of x right here. Our slope was up 1 over 3, and g of x, we can see that called right here, has a slope of up 1 over 2, right? We use that m notation for slope. So the question is, which graph has a larger rate of change? Well, visually, you might be able to see which one is steeper. However, we also need to know which fraction is bigger between 1/3 and 1/2. And if you're not sure, you can always, draw yourself a cute little picture. Split this into a half, right? Or you could split this into thirds. And visually, if we look at this, which one is bigger? Well, 1/2 is certainly larger. You could also use your calculator and you could turn this into a decimal, 0.3 repeating and 0.5, and 0.5 is certainly larger. So when they ask which one has a larger rate of change, I would say g of x has a larger rate of change because the slope for f of x is 1/3 and g of x is 1/2. So make sure your partner signs your paper, get your original paper back, find a new partner, and you're moving on to problem 2. Problem 2, you're looking for x-intercepts. Think about substituting in zeros into the equations and then isolating x. The graph is a little quicker. And then once you're up to about 5 minutes or so for this one, go ahead and unpause the video. I'll run through it. You make sure you did it right, and then move off to a new partner. Ready, set, go. All right, we're back. Let's look at the setup for each of these first. We're trying to create a point something comma 0. That's going to find our x-intercept. And if you're not quite sure why, well, take a look at this graph over on the right, right? If we're looking for an x-intercept, just think to yourself, tell me to stop when I get to the x-axis. Oh, that's the y-axis. The x-axis is all the way over here. So the x-intercept is this point, which is 5, 0. So our x-intercept for the graph is 5, 0. Or you could say that the x-intercept is 5. So let's find the others. Notice that the y value was 0. That's what causes a point to be on the x-axis. So for each of these equations, and I'll zoom in, you might have to write a little small, we're going to replace the y's with 0. All right, there we go. Okay, top equation goes pretty quickly. We need to isolate x, and before we do that, we should probably simplify. This 2 times 0 piece is just 0. But if it's just 0, we don't even write that. Tricky part though, a lot of students forget this. Don't forget to bring your negative down. And then ask, is x alone? Well, no, there's a -3 that is multiplying by x. So we should probably go through and divide off the -3 so that x is alone. And that leaves us with +4. So my x-intercept for function 1 is +4. For function 3 is +5. We still need to find function 2. Function 2, we need to isolate x. I think most of us would probably start with a bit of distributive property, 2x minus 2 minus 10. And of course, some combining like terms. I'm probably going to run out of room, so I think I'll have to use a little bit of space over there, but that's all right. X is not alone. We need to work our way through SADMAP here. All right, we have this 12, which is subtracting to x, and the 2, which is multiplying. SADMAP tells us to undo the subtraction first. This leaves us with 12 equals 2x. And like I said, ran out of room here. We still need to undo the multiplication though. So let's divide by 2. And that leaves me with 6 equals x, or the point 6, 0. So out of these three functions, the function with the larger intercept is function 2. And that's because I found the values of each of the x-intercepts. Those are, I'm just going to do f1 was a value of 4, f2 was a value of 6, and function 3 was a value of 5. Clearly, 6 is the largest of the three of those, and we should be set. So please go ahead, have your partner sign this, or sign your partner's paper, please. Switch papers back so you get your original, and you're off to a third partner. The third problem asks about rates of change, which we know from the opener is the slope. And my hint for each of these is you're definitely going to need to use your slope formula. Okay, so good luck with that. You also might want to involve your calculator to help you simplify some fractions. Whenever you're done, check with your teacher, sign your partner's paper, and then hang tight for a quick second and we'll unpause this video and call it good. Ready, set, go. All right, you're back. Let's go ahead and try to find some slopes here. Now, I'm going to go through and actually use the 2 points that are furthest apart on here. This is going to get us a slope that looks the least correct. That way we can talk about simplifying. So points-wise, we have -4, -5, and we also have the point 10, 2. Okay. As we label these, x, y, x, y, x1, y1, x2, y2. We still have that slope formula hopefully written down on the first page. We know the y's go on top. y2 minus y1, x2 minus x1. And if we do the math here, I'm looking at 7/14. Now, 7/14 is fine for an answer. However, there are two things we'll probably want to do for this. First, it's always a good idea to reduce your fraction. We're looking for a number that goes into both 7 and 14, and there isn't too much that goes into 7. I think if we divide them both by 7, we should be able to see that this is the same as the fraction 1/2. However, if you weren't sure how to get that, we could have just done, on our calculators, 7 divided by 14, and your calculator would get you the decimal 0.5, which is the same as 1/2. And what you'll find is for any of these combinations of points over here, they will all reduce to 1/2 or give you the decimal of 0.5. It does not matter which combination you use. So we know that our first one, the slope of f of x, was 1/2. However, we still need our slope for g of x. So let's go ahead and do the same thing over here. We have our x, y, and we'll zoom in on that. First x, first y, second x, second y, 1/3, 7/3, -4, -2. As we go through, we can do the denominator first. You can type all the denominator into your calculator if you'd like to get your answer. You can also remember that two negatives make a positive. -4 plus 2 is going to give us -2. And then we have the numerator. You can also type all of this into your calculator. Just watch those parentheses. 1 of something minus 7 of something is negative 6 of those things, negative 6/3 in this case. I think we could probably use some simplification here. If you do negative 6 divided by 3, you'll get negative 2, and the denominator is also negative 2. From here, we can reduce, or you can realize that anything divided exactly by itself is 1. So actually, even though we started with some strange fractions, we found that the slope is 1 here, which is a pretty nice number. And so we had to state which graph has a larger rate of change. Well, g of x is going to have a larger rate of change. 1 is certainly bigger than a half. Sign papers, switch back, and you're moving on to problem 4. Problem 4 wants you to figure out which function has a larger y-intercept. And although you could count down and over, try to maybe write an equation for each of these. And when you're going to write an equation, I would really suggest that you use HK form. So just a reminder for your HK form here, you need a slope and a point. We practiced doing this in 3.3 as well. So when you've got your slope and your point, you're going to have a blank, blank inside, blank outside. So go ahead, try to write an equation first. Then once you've written an equation, see if you can figure out what the y-intercept is for each equation. Ready, set, go. All right. Hopefully you guys had some success here. Let's start with the slopes. Looks to me like our slope is down 1, 2, 3, and then over 1. So I'm looking at down 1, nope, sorry, down 3 over 1. There we go. On the second one, it looks like we're moving upwards. We're going up 1, 2, 3, 4 over 1. There we go. Then we can go through and find a point that's on each graph. For example, I've got a point right here. This is negative 3, comma 1. Opposite of h, so positive 3, positive 1. And there's my first equation. On my other function, we have a point, let's see, we've got a bunch of them. Here's a point, 3, comma 1. So positive 3 becomes a negative 3, positive 1. Well, now I have equations here. How does that help? Well, there's two different ways to find a y-intercept. One way you might remember is we could distribute and convert this to slope-intercept form, because in slope-intercept form, the b value is the y-intercept. So let's try that. I'm going to distribute negative 3 over 1 to both of these, but don't forget that negative 3 over 1 is just negative 3. So negative 3 times x is negative 3x, negative 9, and a positive 1. Finish combining like terms, just like we did in 3.3, and this gives me negative 8. So it looks like this graph over here has a y-intercept of negative 8. But there is another way to do this as well. We could also just create the point that is the y-intercept, and we know the point for the y-intercept always has an x value of 0. Nothing on the x-axis, it's all about the y. And so to do that, we need to replace the x with 0. Now 4 over 1 is again the same as 4, so no reason to write the over 1. I'm just going to follow PEMDAS here. 0 minus 3 gives us negative 3. Negative 3 times 4 is negative 12. Plus 1 will give us negative 11. And there we go. We have two y-intercepts. We need to identify the larger of the two. The larger of these two y-intercepts is certainly negative 8. Seems weird. You're like, but 11's bigger. But if you think about our axis, right, if we extend it way down here, here is, I'm going to erase this for some clarity. I'll put it back in a second. But here would be negative 8, and here's negative 11. Larger is more positive. Negative 8 is a larger number than negative 11. Okay. So, I said I'd put all that back on. There we go. So that tells us that f of x is the one that has the larger y-intercept. The graph with the larger y-intercept is f of x. I know this because the y-intercept of f of x is negative 8, while g of x is negative 11. Okay, at this point, you guys have 2 problems to go. Hopefully this hasn't been too terrible. So go ahead, find that next partner. This one is quite tricky. You're going to probably need a little bit longer on this, but we need to find the y-intercept of the function with the larger rate of change. Whoa, Nelly. Right? And there's a hint here, though. Find the slope of each function first, and we've done slopes before, and then write an equation. All right, so you've got quite a bit to do here. Go ahead and find the slopes first, then find the y-intercept. Ready, set, go. All right, let's go ahead and start with the slopes for each of these, right? Because we want to find the y-intercept of the function with the larger slope. So let's find which function has the larger slope first, then we can tackle the y-intercept. So slope-wise, I'll do the same thing that I did before. I'll take the 2 biggest points. It's probably easier, honestly. Let's do the easier way. It's probably easier to take the 2 smaller points when you're doing all this math here. So we have the point 0, negative 1, and also the point 6, 17. I'll label my points x, y. Zoom in. X, y. First x, first y. Second x, second y. And now we find our slope. Don't forget to put in those parentheses, otherwise you're going to miss a negative and then you'll be sad. And then I'll be sad. We don't want that. So we put the y's up top. I like to start with the second y. Then we'll put the first y, second x, first x. So we go through. 17, this is a plus 1, becomes 18 over 6. And 18 divided by 6, try it in your calculator, you'll get 3. 3 over 1 if you want, or just 3. So we have the slope for the first one, but we want the y-intercept of the function with the larger slope. I don't know what the slope of the other one is yet. So what are we going to do? Oh, of course, we're going to find the slope. So let's label these as well. We have our x, y, first x, first y, second x, second y, and slope time. Looking good so far. Excellent. So y sub 2, y sub 1, x sub 2, x sub 1. 9 minus 7 is 2. 3 plus 1 is 4. And then we reduce. Top divided by bottom will either give you, if you divide by 2's first, you can choose to do that. That will give you 1 over 2. Or if you do the top divided by bottom, you'll get the decimal 0.5. All right, so now that we're here, we have 2 different slopes. We have to determine which one is larger. Well, I'm pretty sure that 3 is larger than 0.5. So now that we've determined that f of x has a larger slope, now we need to find its y-intercept. Okay? Well, how do we find the y-intercept? Well, there are a couple ways to do this. I did suggest writing an equation for each one, so let's do that first, and then we can see if there might have been a faster way to tackle this. So equation-wise, we've talked about using HK form in the past, so let's continue with that trend. And I'll do the same thing over here. Now, we don't actually care about this blue equation that I'm writing with because it didn't have the larger rate of change, but it's probably worth discussing how we could have done it. So my slope here was 3. And then let's use a point. I'll just use 6, 17 because it's here. Minus 6 plus 17. There we go. And if I wanted to do the same thing with the blue equation, 0.5 or 1/2, up to you. And then which point do you want to use? I'll just use 3, 9. So minus 3 plus 9. There we go. Now, for either of these equations, if we want to find the y-intercept, you could just replace the x's with 0. Right? For example, if you wanted to show it on the blue equation over here, you'd replace the x with 0. And then you'd do the math. Okay? Mathematically, we would end up getting something like 7.5. You can actually put all of this into your calculator if you want. But we don't actually care about this side. We want the y-intercept of the function with the larger slope. This didn't have the larger slope, so this part is kind of all unnecessary. Over here, we could do the same thing, but I wanted to give you a couple options just to help you be a little efficient here. So one option is, of course, we could replace the x with 0, put it into our calculator. Another option is we could distribute the 3. Now, in fact, let's look at that really quickly. 3x minus 18 plus 17. And if we combine like terms, that gives us minus 1. So as soon as we're in slope-intercept form, we should be able to see that my y-intercept is negative 1. But actually, I think all of this was unnecessary again, because if you look back up at the table, do you notice our answer anywhere in the table? I see a negative 1 up here. Do you think it's coincidence that there's a negative 1 in the table and it happens to be our answer? I don't think so, because in our table we had a point 0 comma something. In fact, if I wanted to sketch a quick graph of this table, and I'll just do it over on the side, you could sketch it on your paper if you'd like, right? Look at these points. I have the point negative 4 comma negative 13, which I'm just approximating down here. I have the point 0 comma negative 1, and then I have 6 comma 17, and last but not least 10 comma 29. If I connect these 4 points, does one of those points show the y-intercept? Well, it does. The y-intercept is 0, negative 1, and if you can remember that a y-intercept always has an x of 0, we could have actually seen the y-intercept in this table right away. And so as soon as we got 3 and 0.5, we realized we're done with this one. We didn't even have to write an equation because they wanted the larger y-intercept and we already had the y-intercept. Great, we're all done. Now, if you didn't realize that, you still could have done the equation, no problem. So read carefully on these. That's definitely a tricky question. Let's sign that paper, switch back, last partner of the day. Here comes problem 6. Two functions are given below. When you sum up, what does it mean when you sum up numbers? I think that means you add them, right? When you add up the x and y intercepts for each function, which function has the larger sum? Woo, Nelly. So I think you should probably start with your partner by finding the x and y intercepts for each function. And then once you found each one, maybe try adding them together. And as a hint, there are no zeros here, so we have no x or y intercepts. I would really suggest that you start by writing an equation for this guy right here. Write an equation first, and you might even run out of room here. Sorry, you might have to use some room down below. There's quite a bit of work involved with this guy. So, last problem for the day. Let's see what you guys can accomplish. I'm excited. Ready, set, go. All right, let's tackle the easy one first, I think. We're going to tackle the graph, because on the graph we can actually see the x and the y-intercepts, can't we? Our x-intercept is where our graph crosses the x-axis. Y-intercept is where it crosses the y-axis. So we know that the x-intercept is 4 and the y-intercept is negative 3. If I want the sum of those, we need to do 4 plus negative 3. That's like 4 minus 3, which is 1. So my graph has a sum of 1 when we sum up the x and y intercepts. Let's go ahead and tackle the table, the big kahuna. First things first, let's find our slope. Slope-wise, we'll pick 2 points pretty close together. I'll just stick with the positives here, right? We can see that we have, and we'll just maybe use our table like this. We have first x, this is the second x, first y, second y. Let's go ahead and find our slope. Hopefully not taking too much space because we're going to need it in just a bit. We have our second y, second x, first x. I'm looking at 4 over 3. Oof, rough slope. Okay, 4/3 is our fraction, doesn't reduce. Let's go ahead and now write our equation. Equation-wise, if we use our HK form, we know our slope is 4/3. And we need a point. Doesn't matter what point you pick, totally up to you. I'll go ahead and just pick the one at the bottom, might as well. And so it's going to be minus 9 plus 8. Okay, what's next? Well, I'm going to go ahead and simplify this and kind of cross my fingers and hope things work out. I'm going to convert to slope-intercept form. And so this is going to give me 4/3 x. And then we have to do 4/3 of 9. You should have done this on your calculators before. You can also do it by hand, and I'll show you how to do both ways right now. So 4/3 times -9, I'm just going to use some space over here. So 4/3 times -9. Well, if we wanted to do it by hand, we need to remember fractions are multiplied straight across. Okay? This gives us -36 on the top, 3 on the bottom. And if you divide -36 by 3, you get -12. The other way you could do it is on your calculator, type exactly this. Parentheses 4 divided by 3, closed parentheses. We always want to group our fraction in parentheses just so we don't lose any numbers. And then times, and then we need a -9, not a minus, but a -9. And when you press enter, hopefully you end up with -12. All right, either way though, we have -12, so minus 12, and then there's still a plus 8. Finishing cleaning this up, 4/3 x, -12 plus 8 is -4. How did this help us? Well, at least it gave us our y-intercept for this equation, right? That's this guy hiding over here, slope-intercept form. So we've at least got our y-intercepts for each one. But what do we not have? Oh, that's right, we don't have our x-intercept yet. Bummer. Okay, well, x-intercept-wise, I do need a little bit more room here. So I'm not sure where we're going to make this work in terms of room. Maybe I'll just kind of use this center section right here. I'm trying not to go off the paper because you guys don't have that luxury. If we're going to find an x-intercept, we need to remember that x-intercepts always have a y value of 0. Tried to do that backwards. Whoops. So that means we're going to take our beautiful equation here, and we're going to replace the y with 0. At this point, we need to solve for x. SADMAP tells us to undo the addition and subtraction first. Gives me 4 equals 4/3 x. And then we have a couple ways to do this, but a way I've seen a lot of your classmates use, which I really like, is they undid dividing by 3 first by multiplying both sides by 3. That'll cancel those out. 3 times 4 is 12 equals 4x. And then last but not least, they divide off the 4. And doing that will give us that 3 is our x-intercept. All right, we've now found our y-intercept and our x-intercept, but we still don't quite know the answer to this because we have to find the sum of those two. So if I want the sum, just using some space down here, we have our x-intercept plus our y-intercept, and that gives us -1. So the sum of the x-intercepts of g of x, that's this guy over here, was -1. The sum of the f of x intercepts were +1. Which one is larger? Well, +1 is absolutely the larger one, or the ones from f of x if you'd like. All right, that's all we have for you today. Hopefully this unit has done a good job of first, right, we talked about domain and range and functions, and then 3.2 we went through function notation. We used that a decent amount. 3.3, we talked about how we can write lines. And then 3.4, now that we were able to write lines, we could do a good job comparing them, whether we got them in a table or a graph or just from points. So thank you for tuning in. And next class, we'll get some practice for our Topic 3 exam coming up, which is the class after that. Excited to have you back. Keep up the great work. Have a wonderful day.